we're going to talk about pre, quasi, and true experimental designs. This is just like an X and O way of talking about study design. There's a left to right orientation, which indicates the progression of time from before to after treatment. And a vertical orientation indicates a simultaneous occurrence. So this will make more sense as we go through it. X's are our experimental treatment. O's are our observation or measurements of the dependent variable, right? So X would be the independent variable. R, when subjects are randomly assigned to groups. MR, when subjects are matched unknown extraneous variables and then assigned to groups. And the dashed line, when there are no formal means of certifying attempts to equate groups in an experiment. The first type of design we're going to talk about are pre-experimental designs. This is sometimes also called single group designs, and it's usually conducted for exploratory purposes or to describe a therapeutic effect or outcome. This is considered a weak design because it has inadequate internal and external validity. You can't confidently determine a cause and effect relationship between the variables, and you can't generalize the results beyond the group of subjects studied. There's marginal control over environmental and extraneous factors and provides weak evidence of treatment efficacy. However, descriptive and exploratory studies do serve as a role in establishing treatment efficacy. So this would go back to like a phase 1 study. For example, a one-shot case study design. This is a weak design. We have a treatment and then we have an observation. So a single group is observed only once after having been exposed to some treatment. There are major problems in that there's no reference point for comparison. So we have no pretest, we have no baseline, we have no control group. There's just a treatment and then an observation. The effects cannot be evaluated because there are no comparisons. Like I said, there's no pre-treatment performance group, and there was no control group that did not receive the treatment. There's no basis for the conclusion that the treatment affects the scores without pre-treatment and control group comparisons. There's no evidence to indicate that a performance is better after treatment than it was before. This is another pre-experimental design. This is a little bit stronger than before, but it's still a weak design. So we have an observation, a treatment, and another observation in one group. So we have a pretest, we have a baseline, and then we have the treatment and we have the results. This is a within subject design. All the groups of subjects are tested under two conditions: before the treatment and after the treatment. Okay, so pretest or baseline measurement, treatment, dependent variable results post-test in a within subject group, so within one person. There are a lot of threats to internal validity. History, remember this is going back to last week, events that may have occurred during the course of the experiment in addition to the experimental treatment. Maturation, growth, or development that could occur during the course of a study. Testing. The pretest may increase the subject's ability to perform well on the post-test. So we don't have a group that didn't get the pretest. We don't have a control group. Instrumentation. If care is not taken to be sure that the pretest or the post-test measurements are equivalent, there could be statistical regression. Remember, that's when subjects with extreme scores are tested. So subjects might have been selected for extremely poor pretest scores and therefore considered good candidates for treatment. might only show an improvement. So these threats can be controlled for with a stronger design. This is another type of weak design. Remember, we're still in our pre-experimental designs. This is called a static group comparison design. So we have treatment and an observation, and then we have another observation. So we have a control group, but we're still missing some things. So one group is exposed to an experimental treatment that is compared to another group that hasn't been exposed to the experimental treatment. But we have no pretest, and we don't know if the two groups were randomized or matched. We don't know what the external validity is. That was a between subject design because we were looking at two groups because we had the control group. But the major problems in this test were no pretest against which to compare post-test scores, no formal means of certifying equivalence of the group's unrelevant extraneous variables. Any difference between the two groups may not be a result of the treatment program alone. With the static group comparison design, threats to internal validity include, again, subject selection, a lack of knowledge about extraneous variables in both groups, experimental mortality, no way of certifying those extraneous variables.